solutions, we also covered the concept of discriminant and how to use discriminant as a tool to finding the number of solutions. Today, I want to talk about two equations, solving two equations. So I'm going to start with this one. And for this particular equation, we're going to look at both the factoring method as well as using the quadratic formula. And then it's up to you which method you want to use. You already know that there are a lot of equations, a lot of quadratic functions where we cannot just simply use the factoring method because it does not just simply work. So we have to use the quadratic formula. Guys, one has to know both the factoring as well as the quadratic formula. At the end of the day, if factoring works, one should actually try to use factoring rather than using the quadratic formula. But if factoring does not work, then one has to use what we like to call as the quadratic formula. Okay, so let us first look at this particular example. Let us focus on, let us try using the factoring method first. So before we start using the factoring method, we already know that we have to transform this into a standard form, which looks like ax squared plus bx plus c equals to 0, which can easily be accomplished by subtracting 5 from both sides. So I'm going to do that. And then we also have to do some rearranging here so that we have the x squared terms first and then x and then the constant. So I'm first going to subtract 5 from both sides. And while I do that, on the left hand side, I'm already going to rearrange this as 9x squared plus 12x, writing it in the standard form, and there will be a 0 on the right hand side. Now it is in the standard form. Now we should be able to use the factoring method. We'll try to use the factoring method and see if it works. Okay, so to factor this polynomial, this quadratic polynomial on the left hand side, what we do first is we take the coefficient of x squared and this -5, we multiply them. What do we get? We get a -45. Then we try to come up with two factors of -5 so that they add up to +12, which is also called as splitting the middle term. So let us come up with the first one. Well, it's not divisible by 2, it is divisible by 3. So 3 and 15, right? Well, 3 times, well, we have to put a negative somewhere. So let me put a negative right here in front of 15. So 3 times -15 gives me -45, but I want the middle term, I want these two numbers to add up to +12. Well, 3 plus -15 adds up to -12, but we want a +12. So I think we can make some changes here so that when we add those two numbers, we get a +12. And if you have already guessed it, it's going to be +15 and -3 because this plus this gives me +12, and this times this is still -45. So guys, you have to start by writing two factors, and then if you have to kind of play around with the signs, go ahead and do it, because we want to make sure that when we add those two numbers, we get the middle term. Okay, from here you already know what to do. You want to break the middle term into two pieces. So I'm going to start by writing 9x squared, and then to simplify or to break the middle term, we already have the two numbers that we are going to break it into. So I'm going to put plus 15x, and then I have minus 3x. And then at the end, I have my -5 equals to 0. Okay, guys, it does not really matter whether you put 3 here or 15 here. That does not really matter. So in my previous examples, where I think probably I only showed you one example where we did splitting the middle term, I would have tried to put -3 here and 15 here. Guys, it does not really matter. That's why I chose to do this example, and I chose the arrangement like this so that I can show you that it does not matter as long as you are doing the mathematically, you are still getting +12 from 15 and -3, okay? Once we have these four terms, then we have to use the grouping method. The grouping method simply is like you group the first two and the second two, right? And you try to come up with the greatest common factor, if there is any. So when I compare these two terms, obviously you can see that the greatest common factor is 3x. There's an x with it as well. And what is left inside the parentheses? Well, it's not too difficult to figure out what is left, because we already know that when we distribute this 3x with this term and this term, we're supposed to get the previous two terms, right? So what should I multiply this 3 to get 9x squared? I mean 3x to get 9x squared. Obviously got to multiply 3x, because 3 times 3 is 9 and x times x is x squared. So that gives me the first term back. I still have to get the second term. Well, what should I multiply this? This is what I'm asking myself. What should I multiply this 3x to get a 15x? So 3 times 5 is 15 and x is right there. So you don't have to do anything about that, okay? That is the greatest common factor for the first two terms, and we have this in the parentheses. Now when you look at these two terms, there's nothing really common between these two, except for there is still that invisible 1, which is common between those two, right? 1 is a factor for every number out there, right? So what we're going to do for the second two pieces, second two number quantities, is that there's a negative here. Guys, since there's already a negative here, so I'm always going to keep that negative. And that is something that I would always suggest everyone who is using the factoring method. If there's a negative right here, you got to keep that negative, okay? Then when you look at these two numbers, you don't have any other common factor except for 1, so you just got to put 1 here. And then inside the parentheses, we're going to see what is left. So what should I multiply -1 to get that? So obviously I should multiply 3x, right? I just have to be careful with the sign because I want a negative back, so this has to have a positive sign. And then what do I get? What do I multiply -1 to get a -5? So it's going to be +5, because -1 times +5 is going to give me -5. Okay, guys, as soon as we see that these two quantities look the same, that means we are on the right track. Okay, so since these two quantities look alike, we can just take them out as a common factor, and then you got to write the remaining terms, and the remaining term is like 3x from the first one, and then we are left with -1 from the other one. Now you have product of two quantities equal to 0, so using the zero product property, we have to set each one of them equal to 0 and solve for x, which is a very simple calculation. Okay, so from here I got 3x plus 5 equal to 0, which gives me x equals to -5/3. Guys, I skipped a step, but I'm sure you would be able to figure this out on your own. And then we have another solution by setting this guy equal to 0, 3x minus 1 equal to 0. When I solve for x, I get x equals to 1/3. So we have two real solutions for this particular quadratic equation, and what the method we used was the factoring method. Okay, now this equation can also be solved using the quadratic formula. So we have the factoring method, we got the solution. Now let us also use the quadratic formula and see how rigorous that is, and then we will also be able to verify whether we get the same answers that we got from using the factoring. Okay, so let us take this up over here. We already have it in the standard form, right? This is the standard form. So from here, we can actually take it up. So I'm doing the same thing, but now I'm using the quadratic formula to do it. So I have 9x squared plus 15x minus, sorry, it is 9x plus 12x minus 5 equal to 0, right? First we identify the a, b, and c. Once we have the a, b, and c, then we use the quadratic formula. Okay, so my a is 9, b is 12, and what is my c? -5 right there. Okay, now let us recall the quadratic formula. Guys, I suggest that we should remember the quadratic formula because it's not too difficult. I mean, once you start using it more often, I think you would automatically remember it. Okay, so the quadratic formula, first I'm always going to write the general form or the general formula, and then we are going to substitute the values. So it's minus b plus minus radical of b squared minus 4ac and divided by 2a, and this term inside the radical is called the discriminant. Okay, we already talked about that discriminant and its properties. Now let us substitute the values and see what we get. So we have x equals to -12 plus and minus. B squared is 12 squared minus 4 times a, which is 9 times -5. And this whole thing has to be divided by 2 times 9. Guys, I just simply substituted the values. That's all I did in this step. In the next step, let us try to simplify. So first, we should simplify the discriminant, the quantity inside the radical, and then we bring it all together and simplify the whole thing. Okay, so it's going to be -12 plus minus. Guys, you got to simplify this. You can use a calculator if you want, or you can do it on your own as well. So I know 12 squared is 144, and there's a -4 times negative, so it's going to become a positive, and 4 times 9 times 5 is going to be 5 times 4 is 20, 20 times 9 is 180. Okay, guys, you can, and 9 times 2 is 18. You can always use a calculator for that if you want to. And now let us simplify this. It's going to be -12 plus minus radical. This is going to be 4, 2, 324, right? That's going to be my simplified form inside the radical. Now we got to simplify this further. Now to do radical 324, first we should see if it's a perfect square. If it's a perfect square, then we can just simply write the value for it. And it turns out that in this case, it is a perfect square. Radical 324 is 18. So you can replace this as x equals to negative 12 plus minus 18 over 18. Guys, please focus on this, because radical 324 is 18. Okay. Now this, we want to break it down into two pieces so that we can see that the final solution looks like what we already got from the factoring method. So there's going to be two solutions. Number one is negative 12 plus 18 over 18, right? Because there's a plus and minus, so we got to have the plus, and then we also have the minus. And if I simplify this, guys, it is going to be negative 12 plus 8 is 6, and 6 over 18. And if I simplify this, 6 over 18 can be simplified as 1/3. So I already have x equals 1/3 here as well. So it confirms that x equals to 1/3 is one of the solutions, because we had that from the factoring method as well. Now let us also make sure that the other value for x is negative 5/3. So the other solution is going to look like negative 12. We already got the plus taken care of in this step, and now we are going to look at the minus 18 over 18. Guys, if I combine negative 12 and negative 18, I get negative 30 over 18. And if we simplify this, what is the greatest common factor between those two? I think it is 6, right? So 6 divides both upstairs and downstairs. So upstairs we get 6 times negative 5 is 30, and 6 times 3 is 18. Guys, here we have negative 5/3. So x is, I think I have just enough room here. So x is 1/3 and x is negative 5/3. Guys, both these methods are in front of you. In this particular example, factoring also works, and of course the quadratic formula works as well. It's up to you which method you want to use when both the methods work. But I just wanted to show you both the methods at the same time. So again, here we can also see that the values for x, the solutions are the same. Okay, so this is still the same type that we talked about in my last quadratic function video. And now in the next video, I will show you one more example of solving a quadratic equation, which is going to look slightly different, but we will transform it into standard form, and then we'll go from there. Okay, so guys, again, I would say you got to practice more problems based on the quadratic equations. And then if you have any questions, please reach out to me, and I'll be happy to help you, give you hints that will help you to be more confident with solving quadratic equations. Okay, thank you. Till then, take care.